This video is on factoring special cases. Sometimes a polynomial fits a certain pattern and can be factored using a formula. Two of these are perfect square trinomials and differences of squares. A perfect square trinomial, sorry about that, hold on. There we go. A perfect square trinomial can be factored into a binomial squared, such as a plus b squared or a minus b squared. Notice a plus b is your binomial and you're squaring it. If you were to multiply each of these out, you would get a plus b squared is a plus b times a plus b. That would give you a squared plus 2ab plus b squared. A squared minus, a minus b, the whole thing squared, is a minus b times a minus b, which is going to give you a squared minus 2ab plus b squared. So if you can recognize a trinomial that is in the form of one of these, a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, then you can simply factor it into the quantity a plus b squared or the quantity a minus b squared, without having to go through some of the steps that we've seen in previous videos. So let's take a look at a couple examples here. Factor each perfect square trinomial. So first we have x squared minus 18x plus 81. Well, the first thing I notice is that my first term, x squared, is a perfect square. So that's kind of like a squared. My last term is also a perfect square. So that's kind of like b. Actually, this one is an x and an x. I'll go ahead and write that out. This is a 9 times a 9. So both of those are perfect squares. Now I'm wondering, is my middle term a 2 times one of these times one of these? And indeed it is, and it's actually a negative 2. Negative 18x is one of these terms. Remember, this was like my a squared. This is my b squared times one of these factors times a negative 2. So this is going to factor into x minus 9 squared, where a is x, my b was 9, and my middle term is that negative 2 times a times b. Let's take a look at this one here. 9x squared plus 42x plus 49. Well, first thing I notice is that my first term is a perfect square. It's actually 3x times 3x. My last term is a perfect square. It's 7 times 7. So this is like my a would be 3x, my b would be 7. So is my middle term going to be 2 times one of these times one of these? And indeed it is, because 2 times 3 is 6, 6 times 7 is 42, and I have my x. Notice I'm going to use the sign that's in front here. So this is going to factor into 3x plus 7, the quantity squared. The other type of special polynomial I'd like to talk about is called a difference of squares. It's in the form of a squared minus b squared. Notice this is a difference, or subtracting two squares. A squared is a square, b squared is a square, and you're subtracting them. This factors into a plus b times a minus b. So let's take a look at a couple examples here. So this says factor each difference of squares, and I have x squared minus 121. So x squared is a perfect square. It's x and x. 121 is a perfect square. That's 11 times 11. So this is going to factor into an x plus 11 and an x minus 11. My next example, I have 3x squared minus 12. Well, 3 is not a perfect square, nor is 12. But the first thing I do want to look for anytime I'm factoring, is there a greatest common factor? And indeed, in this problem there is. I can factor a 3 out of each of those terms. So that's going to turn into 3 times the quantity x squared minus 4. Now let's take a look at what's in the parentheses here. X squared minus 4. X squared is a perfect square. 4 is a perfect square. That's 2 times 2, and there is subtraction. So this is going to factor into 3 times x plus 2, x minus 2. So here are a couple practice problems for you to try on your own. So if you would stop the video and do factor these two polynomials in your math journal. Okay, let's take a look at these. Number one is 20x squared minus 60x plus 45. And in this video, I've been looking for perfect squares, and I don't see any in this. But I do notice that 20 and 60 and 45 can all be divided by 5. So I'm going to take out a greatest common factor of 5, and that's going to leave me with 4x squared minus 12x plus 9. Now, let's take a look at what we have in the parentheses. 4x squared is a perfect square. That's 2x times 2x. 9 is a perfect square. That's 3 times 3. Now I'm wondering, is my middle term equal to 2 times one of those times one of those? And indeed it is, because 2 times 2 is 4, times 3 is 12, and I have an x. So I'm noticing that this is a negative here. So this is going to factor into 5, which is the greatest common factor I took out, times 2x minus 3, that quantity squared. Number 2 here is 7x squared minus 63, and again 7 and 63 are not perfect squares, but I do see a greatest common factor of 7 that I can take out, and so that's going to leave me with x squared minus 9. And I recognize this as a difference of squares. X squared is a perfect square, 9 is a perfect square, 3 times 3, and they are being subtracted. So this is going to factor into 7 times x plus 3 and x minus 3. So in this video, we took a look at factoring two special cases, perfect square trinomials and differences of squares. And actually, if you can get the feel for the pattern of these and learn how to factor these without doing all the extra work, it's going to save you a lot of time.